Hey, come here a second. I want to show you something really cool. Something you probably haven't seen before. This is the Box Turtle. It's an open source, do-it-yourself multicolor system for Klipper printers. But this one claims to be easier to use, easier to build, and much more reliable than other similar systems you may have seen in the past. So in this video, I'm going to share my experiences from the last few weeks of building and using it. What went well, where I got stuck, if and how I was able to overcome some of the hurdles, all in hopes of answering the question: is this finally an open source, do-it-yourself, and usable multicolor system that anyone can and actually should build for themselves? Let's get after it. First, a little bit of background on the Box Turtle. The kit that I am using in this video was provided free of charge by LDO Motors, but no money has changed hands, and this is in no way intended to be a review. The design itself is an open source project, and therefore it is a community effort with many different contributors, but the main dude behind it, as far as I understand it, is Armored Turtle, or Robert Klotz. I probably don't need to explain the name. I mean, look at it. But I will explain a bit about the idea and the philosophy behind it. Essentially, the goal of the project is to create a do-it-yourself, easy-to-use, and reliable multiplexer system for Vorons or any other Klipper machine. More on that later. But whereas the other multicolor system that I built previously on the channel, the Enraged Rabbit Carrot Feeder, or ERCF, and the Tradrack, which is similar to it, both aim to achieve this in the same way as Prusa's MMU unit with servos, selectors, gates, buffers, and filament sensors, the Box Turtle is very much against that method. I mean, just look at the front page of their manual. Can you say shots fired? Instead, the Box Turtle goes the route of the Bambu Lab AMS, the classic one, not the AMS Lite. It trades linear bearings and a servo selector for individual lanes for each spool, each with their own stepper motors, rollers, and respoolers. That means that instead of one motor being reused to feed each of the filaments, you have a dedicated motor for each spool. It also means that instead of a huge buffer that takes up a lot of space, you have these rollers that respool the filament nicely onto the roll. On the one hand, this should all mean that it's going to be much more reliable, more compact, and easier to load. But on the other, it means that this system is nowhere near as affordable as others, and that expanding the system to, say, 12 colors like the ERCF is also much more expensive and a much more complicated endeavor than just extending the rails and adding a few extra gates. Like with the Bambu Lab AMS, you basically need to add on an entire additional Box Turtle unit if you want to go beyond just 4 colors. But unlike the Bambu Lab AMS, because this is open source, you can tweak it, modify it, and upgrade it in the future if, say, you want to add your own enclosure or a filament dryer. Additionally, like most of these types of system, it is highly recommended that you simultaneously upgrade your toolhead to include a filament cutter and 2 filament sensors right in the toolhead if you haven't done so already. Yes, it is possible to do so-called tip tuning and forego those upgrades if, say, you're installing the Box Turtle on a non-Voron printer like an Elegoo or a Sovol and you don't want to tinker with the toolhead. But you will save a lot of headaches and vastly improve your reliability if you just cut off the melted tips instead of trying to tune them. But let's not get ahead of ourselves, because before you tune your Box Turtle, you are going to need to build it. So let's talk about the build experience. The overall build was probably about 10 to 15 hours, not including some time that I spent redoing things that I did incorrectly because I was live streaming instead of reading the instructions. Now, I'm going to say this a few times probably throughout this video, but this is a project, not a product. And I suspect that one of the major draws of this is going to be the fact that it's a really fun project. And as such, it is worth mentioning that it's a pretty enjoyable project. Unlike other things that you may have built in the past, like a Voron or a Prusa printer, which have PDF or printed manuals, the Box Turtle uses not only an interactive STL configurator to help you get a handle on all the things you're going to need to print, but it also has an innovative and interactive online manual that you can customize to match your colors and which allows you to zoom, pan in, rotate, just to get a better view of each step. This is nothing short of brilliant, and alongside the mechanical differences that we're going to get into in a second, it really makes the overall box turtle build experience really enjoyable. Whereas I would summarize the whole ERCF build experience with a firm never again, though to be fair, I did build a 12 unit, which is a lot more work. I would happily build another one of the box turtles if I wanted to add 4 more colors or add it to another one of my Vorons. No offense to the ARCF team here. With that said, this is still TNL and I'm still me, so you know that I still had quite a few issues. First of all, I had issues with the respoolers not spinning freely, which did require me to remove, reprint, rebuild, and remount some of the respoolers 2 or 3 times before I got them moving smoothly. Apparently, the MJF nylon gears provided in the LDO kit are actually causing problems for a lot of folks, and part of the solution is actually to reprint those gears at home in plain old ABS. We also figured out that we had some parts rubbing against either the sides or the bottom of the tray, causing friction, so we had to loosen those up a little bit. I say we because at this point I do need to thank my friend and patron, Jacques, for helping me get these working nicely when I had honestly kind of burnt out of repeating the same step over and over again. So thank you, Jacques. Additionally, I am currently having a frustrating issue with the hub itself and filament getting jammed from one of the lanes. I actually tried to drill it out to improve the clearance on the way out a little bit, and I rearranged the Bowden tubes, and still, sometimes filament gets jammed on the way out. Fortunately, there is apparently a new and improved version of this part on the way, which aims to solve all these issues. But what's more, because the box turtle is fully open source, I can just remix my own version and try and fix it myself without waiting. So if you don't see as many sample prints in this video as you'd hope to, it means that future Jonathan is still working on solving that issue as we speak. But in all fairness, I do have to say that a lot of the fitment and clearance issues on both this build and on my ERCF build likely come down to the fact that, as always, I'm printing a lot of the parts for these different builds on untested and uncalibrated printers that I'm testing for other videos or for sponsors. So I think that overall, if you have a well-calibrated printer and you read the instructions carefully instead of trying to entertain people on a live stream, this is a very doable project. And it was mostly devoid of the types of laborious, odious tasks that can make a build like this into a real chore. Additionally, if you run into trouble, I do want to say that the Armored Turtle Teaching Turtles team is very quick to hop on in an all-hands-on-deck style and get you sorted. And I love that they're using a ticketing system within their Discord server to make information as searchable and accessible as possible, because that has been a major point of frustration for me in the past when I try to do some of these open source builds. The only complaint I have with the build process itself then probably has to do with the point in the build where you switch from the hardware to the software and configuration. By the time you have it assembled enough to begin installing and tweaking the software and the board on your printer, you've honestly become pretty spoiled with the step-by-step guides, and it was a bit frustrating for me at least to then need to go read through walls of text on separate GitHub pages for the AFC controller software and then the box turtle, and then another separate page with the initial startup guide, all for installation, calibration, and initial startup. Maybe my brain was just fried, but I found myself repeatedly asking the folks in the Discord ticketing system which one of these 4 or 5 different resources I was supposed to check in order to find each piece of information I needed at each stage, and then switching back and forth between those 4 and 5 different guides. Maybe it's too much to ask, but I would really like to see the software, configuration, tuning, and troubleshooting stages all added right into that wonderful Box Turtle interactive website with step-by-step pictures of what to tune and calibrate in each step. Because honestly, you guys have really spoiled me with the awesome build experience and this website, and I really hope to see more projects do that. Overall, compared to the ERCF I built middle of last year, I will say that the points here go to the Box Turtle, just generally for being an easier build with fewer frustrations, less annoying assembly work, and a more forgiving design than the ERCF, which definitely has to be perfect in terms of print quality and assembly to function properly and reliably. Up next, let's talk about configuration and calibration, because that is a major part of getting one of these systems to work properly on your printer, and it's the part that has definitely beat me and many others with the Box Turtle's predecessors. Even though, as I mentioned before, it can be a little bit confusing to figure out where you should be looking at each of the later stages of the build, I will admit that the creators of Box Turtle and its complementary software have kind of already thought of everything. Many parts of the configuration are fully automated, such as the system calibrating the Bowden tube length and the buffer, and others have been figured out for you, for example, with readily available retraction values for each of the major and popular hot ends used on Voron builds. The only things you really need to tweak yourself are the macros. For example, you need to teach the printer where to park and where to brush the nozzle and all that different stuff, as well as, of course, where to cut the filament. All of this is very well documented within the files themselves as useful little comments, and even if you don't have a step-by-step list of what to configure, at least not yet, it is very easy to go through and change all the variables that you need to change to get things up and running. You'll also need to change your print start macros, which is a little bit more of a, here's an example, go figure it out yourself, but it's nothing insurmountable. I'd say that after maybe 2 or 3 hours of tinkering, even I, who is not good at Klipper macros and stuff, had the Box Turtle running well enough to attempt my first sample multicolor print. I did, however, have another frustrating issue with major layer shifts happening after cutting, and I spent an hour or more tweaking my sensorless homing values, adjusting the cut distances, testing, doing it again, and then doing dry runs of cuts. I ultimately solved the issue by really honing in on how far the toolhead needed to travel to make the cut, as well as changing the cutting position from an absolute max of 350 to just 347. Oh, and I also figured out that my flying gantry was quite literally flying because the back mounts on the carriage had actually worked themselves loose, which definitely did not help with the accuracy of my sensorless homing. So, oops. Compare this to the ERCF calibration process, and again, the difference is honestly night and day. I personally spent maybe 20 hours trying to get both the software and the hardware perfectly tuned on my ERCF before ultimately giving up, and I have spoken to others who spent as much as 60 hours in order to get it working perfectly. So here, once again, it's not a competition, but the points are definitely awarded to the Box Turtle. Now, in a second, I promise we will get to the actual user experience of day-to-day use and hopefully some sample prints. But before we do, I do want to talk about the software experience in case you're wondering what it's like to run this on your printer. So unlike most of the other systems like the ERCF that use something called Happy Hair, the Armored Turtle is designed to work with its own software plugin for Klipper called AFC, or I think Automatic Filament Changer. This is a newer but much simpler system, and it works quite well with the Box Turtle right out of the box. Get it? Out of the box. Unlike Happy Hair, there is currently no Klipper screen plugin or Mainsail dashboard module. Correction, there is now a beta version of Mainsail with a full graphical user interface for managing and remapping the filaments. And I can't imagine that a Klipper screen plugin is too far behind. Personally, I always found Happy Hair to be really powerful, but also really complicated and overwhelming. So I do welcome the much simpler kind of magic happens behind the scenes approach of AFC. But I also do look forward to being able to actually see filament status both in Klipper screen and in the web interface itself. As far as slicers go, it is highly recommended to use Orca Slicer, and you will need to make some changes in the printer G-code before you can actually print. I love this because I'm a die-hard Orca Slicer user, but you can also apparently configure Prusa Slicer or Super Slicer to work with this setup. All right, now that we have covered just about everything that you'll need to know to get up to this point, let's talk about the day-to-day user experience with the Box Turtle. From a slicing perspective, printing multicolor objects with this setup is really no different from on a Bambu Lab printer. You add the filaments, you paint or otherwise select the different colors that you want, and it kind of just does its thing. But truthfully, that's really the only interaction that you're going to have with the Box Turtle because it really is designed to just work. Loading filament is really easy, much easier than on other systems that require you to wrap the filament around a buffer. The system begins pulling filament as soon as it's inserted. You do need to push the filament in quite a bit, like 10 to 15 centimeters, but it will eventually pick it up and then load the filament for you. There are helpful LED lights on the front which will let you know when a given lane is in use, loaded, or empty. Unloading filament is a little bit more of a hassle because the box turtle's extruders always grip onto the filament. But because there is now a beta mainsail version, as I said before, this is at least a little bit easier, though I hope that there will be a clipper screen module soon as well. When things do go wrong, the box turtle makes it pretty easy to fix them because the entire bottom of the unit is open and very spacious. It's not as good as being able to do it from the top, like in the new Bambu Lab AMS 2 Pro, but it is definitely easy to unload and unclog. You can easily get in there, lift the thing up, remove the Bowden tubes, unclog the filament, and just be on your merry way. But now I am going to go and try and fix this hub issue, and then we'll hopefully switch over to future Jonathan to see if he solved that issue so that hopefully we can see some finished prints.
Several days later.
Okay, Philifam, I'm back with an update, and I'm afraid it's not the update that we were all hoping for. Let me tell ya, it's been a journey. That lane 4 gem issue really put me through the ringer for a couple of days, and I ended up trying, I think, like 5 different prototype designs for that central hub, and then I changed the motor angle, I changed the chamfering of the PTFE tubes, a lot of different things. In the end, what ultimately got it working was I realized that I had a 3mm inner diameter PTFE tube in lane 4, which may not have been centering the filament correctly. Oops. B, I tried a new design for the hub from Rolf in the Armored Turtle Discord group. And C, I tried printing the hub out of a special ultra-low friction PETG plus Teflon composite that Fiberlogy sent me to try out. Whatever it was, filament swaps are now working very, very smoothly, though of course, now that I've written and recorded that, lane 1 seems to be giving me some issues all of a sudden as well. But as I write and record this, I have done multiple thousand filament swaps, mostly without a hitch, which is a lot more than I can say for other systems that I've used in the past. And I've even done some sample prints, which by the way, are just a couple of the many, many models available on today's video sponsor platform, STL Flix. Now I printed out this 2-color Panda kit card out of Polymaker Polyterra PLA, which as you can see, I used to test the lower limits of the flushing volume multiplier. Obviously, you have eyes. You can see that I figured out that I did need a higher flushing multiplier than I used on this one, but that's kind of why I chose something small like a kit card with such clear, contrasting materials. Overall, though, the color separation is very good once the purge is completed, and this kit card, I think, besides that, turned out beautifully. I also wanted to try this customizable poker chip that STL Flix offers, just to see how well things were tuned on my printer, and once again, to test the purge multiplier. You can see that I did get the purge a little bit closer, but it is still not nearly conservative enough. And this definitely should not have been printed on a 0.6mm nozzle, but still, color separation was good, switches were working well. This was definite progress. But here, I do want to say that although the quality of some of the half prints that I'm showing you now on the screen is pretty phenomenal, the more I think about it, the more I think that it is kind of silly to actually rate the print quality on a system like this. Like, it's an open source system which uses my own existing personalized profiles in OrcaSlicer, and I can tweak every parameter of both the slicing and the macros that conduct the switches. I can tweak things like how much the filament retracts before being cut, how much filament I want to waste, whether it poops into a tray on the side of the bed or makes little blobs that it flicks away. I can tune if it purges into a useful purge object or prints a purge tower. So ultimately, both the print quality and really most of the reliability besides the actual hardware stuff is up to me and how well tuned my printer, my profiles, and my macros are. Compare that to a more closed system like the Anycubic Cobra S1, which I used to print this Moonman night lamp, also from STL Flix. It turned out very nice, but you can see that the provided profiles weren't exactly flawless, especially for silk filaments. Now I've since jailbroken that printer to run mainsail and made my own improved profiles, which I shared with my patrons on my Patreon, but all that's besides the point. I guess what I really want to point out is that the beauty of an open source system is that you aren't dependent on someone else pushing new profiles or more reliable macro improvements if you have problems with your particular setup, like I have. Or maybe I just wanted to show off some amazing prints from our sponsor, STL Flix. Now, you are probably wondering, why don't I have more sample STL-Flix prints to show you? After all, I've really taken to heart the feedback from all of you that you want to see more sample prints when I review systems like this. And actually, I had already written up this amazing script and this wonderful integration with our sponsor where I would show off the print quality by using some of their amazing multicolor models, meanwhile talking about STL-Flix and how amazing it is and how they have 2,200 models you can download and instructions. It was going to be like the best, most natural, and least intrusive ad integration ever. I was really excited about it. So what gives? Where are the sample prints? Well, unfortunately, as much as I do want to keep up the momentum from last week's video where, I actually finished some projects for once, I did hit up against a lot of obstacles and hurdles. First of all, I have had print failure after print failure after print failure. There was the lane 4 loading issue that I mentioned before, but even once that was resolved and I had the box turtle hardware working flawlessly, as you can see, and I'm sorry, here behind me, my printer then started acting up and losing the connection to the MCU, probably because I had too many USB devices connected at once. And even once we resolved that by unplugging one of the extra nozzle cams, we ran into a weird issue where the purge tower would actually print in mid-air for the first couple layers. And despite trying to save those prints with some hot glue, the print would eventually collide into the purge tower and it would just make a huge mess and then cause the print to fail. And even now that all of that has been resolved, I still have a bunch of issues with layer shifts, probably not due to the box turtle, but because of the fact that my sensorless homing still isn't quite as accurate as it needs to be. I mean, as someone in the Armored Turtle Discord group said, sensorless homing is usually great. It's usually accurate enough unless it comes up against rigid objects that don't move, like the pin for the filament cutter. The bottom line is I don't want to make any excuses, but I've been trying to get some of these impressive, beautiful multicolor models from STL-Flix printed out in multicolor for like days, and it just isn't happening. Now, maybe I'll have something to show in the last minute, which I will put in here if I do, but honestly, next week is Passover here. I'm headed on vacation with my family, and my oldest son is also homesick. So kind of a perfect storm of events, and I do have to get this video over to Eric so we can actually edit it and release it in time. With all that said, I do look forward to doing even more multicolor prints on this system now that, as you can see, I mostly have it working very well. And I'll be digging through STL-Flix's extensive library of functional prints, trinkets, and more to find fun stuff to print. I'll probably do a bunch of YouTube shorts once I get some successful prints under my belt and have something to show. So if you want to see updates or print quality samples of what this system is capable of, then make sure you're subscribed. And for those of you who haven't heard of STL-Flix, I know I've probably said that name like 20 times by now, but you should definitely check it out because they have literally thousands and thousands of models, including do-it-yourself projects or other useful objects, all that you can download for one low monthly fee. They even have a commercial license where they provide you with not just the designs and instructions to build them, but also pictures and videos, and really everything you need to start your own 3D printing business. Also, members can now buy STL-Flix brand filament for as little as $10 a kilo, making the overall membership an even better deal. Sponsors like this make these videos possible, so if you're looking for great models to download with more added like every week, definitely visit the link in the description today. So, what's the final verdict here? I mean, when we embarked on this video, I promised that I would tell you, based on my own experience, whether or not the box turtle lives up to its stated mission. Is it actually an open source, multicolor system that is easy to build, easy to use, and reliable? Well, yes, mostly. Though I had a lot of issues getting it running. Did my print just fail? And I'm still working out some of the old kinks and new kinks that are presenting with the amazingly helpful Armored Turtle team. I do think it's important to remember a few things. Number one, I'm an early adopter, and the team has been incredibly responsive in creating solutions for each of the problems I've found as I've encountered them. So like so many of the projects that I take on this channel, I had to walk so that all of you could ultimately run. Number two, at literally a couple thousand successful swaps under its belt, this system is already working way more reliably than any of the other systems that I've built in the past, and arguably even more reliably than some of the commercial systems that I've used early on in their release. And number 3, I'm me. I am notorious for not reading the instructions, putting the wrong diameter of Bowden tube where it shouldn't go, brushing over the step where I actually calibrate my sensorless homing, neglecting to notice that my gantry is literally not connected to anything, and just generally creating massive headaches and issues for myself. So, do I believe that the majority of you watching this would be able to build this system in a reasonable amount of time and get it working using the resources available at the average person's disposal? Yes. Do I believe that most of the issues that I've had, both software and hardware, will be resolved by the time pre-orders ship out to end users? Definitely. Do I feel that I could say the same about the previous systems that I've built? In all honesty, no. And in the case of the ERCF, I do recall the creators agreeing with me on that. Still, I don't think that the box turtle system is for everybody who owns a Voron or Klipper printer. And that's namely because all of those ease of use, reliability, and conveniences that create such a robust system come at a cost, literally. Whereas a 12-color ERCF will set you back something like $179.99 plus the cost of filament, a 4-color box turtle kit with all of the extra steppers, sensors, etc. will cost you $299 to $315. And that doesn't include at least a kilo of filament, or the extra $205 you're gonna have to spend if you want to enclose it and put in a filament dryer in there as well. So yeah, it gets pretty expensive pretty quickly. I mean, you could basically buy a full multicolor printer setup for that price. You could also be forgiven for comparing the price of the box turtle kit with the rumored price of the upcoming Big Tree Tech Vivid multicolor system, which comes fully assembled and is enclosed, and which they're targeting to sell for $250. And it becomes an even harder comparison and sell then. Obviously, I can't actually compare that system to this one in terms of reliability, quality, or ease of use, since the Vivid is still very much in the prototype phase, but knowing Big Tree Tech, I am sure it is going to be a high quality and reliable product, ultimately, when they get it done. So here's what I'd say. If you're looking for a fun project and are interested in trying a multicolor system for your Voron or Klipper printer, this is definitely worth trying out. If you've been intimidated by what you've read online about other multicolor systems like the ERCF and the difficulties of getting it to work reliably, then this might just be the exact kind of setup that you've been looking for. And if you're the kind of person who'd rather build your own printers versus buying them so that you know the ins and outs of how they work and you can tweak them to work exactly the way that you want, then this is definitely going to be right up your alley and possibly the best option out there. But on the other hand, if you're just looking for the cheapest route to having the most colors or looking for an off-the-shelf product that will quickly add multicolor capabilities to your Klipper printer, yeah, this probably isn't for you. If you do want to give this a try though, I would love it if you use my referral links in the description below, because that does help support the channel and helps us make more great content for all of you. And with that, let me once again thank the Armored Turtle team for all of their incredible help and support throughout this process, LDO Motors for sending over this kit for me to try, and STL Flicks for sponsoring this video. Links to all of the above and much, much more are in the description. That's all for this week, but I'll see all of you on the next layer.